function f is increasing on the interval 0 to 2, 4 to 6, and 8 to infinity because the derivative is positive since the graph is above the x-axis. The function f is decreasing on the interval 2 to 4 and 6 to 8 because the derivative is negative since the derivative graph is under the x-axis. Function f has a local maximum at x equals 2 and 6 because the derivative graph crosses the x-axis and changes sign from positive to negative. There's a local min on the function of f at x equals 4 and 8 because the derivative graph crosses the x-axis and changes sign from negative to positive.
The function f is concave up on the intervals 3 to 6 and 6 to infinity because the slope of the derivative graph is positive on those intervals, and then the graph f is concave downwards on the interval 0 to 3 since the slope of the derivative graph is negative. The graph of the function f has a point of inflection at x equals 3 since the graph changes from concave down to concave up, or in other words, the second derivative changes from negative to positive.
If you look at the graph of f prime x, you can see that the graph is positive up until 2, meaning that the original graph is positive up until 2, but then the derivative goes negative past 2 all the way to 4, meaning the slope goes down all the way till it hits 4, where it's a local max. But then at 4, it goes all the way up to 6 as positive. But at 6 it's not differentiable, so you have to have a corner. And from 6 all the way to 8, it's a negative slope again, so you go all the way back down to 8. And from 8 to infinity, it's positive, so it just goes back up.
Okay.